All right, let's talk about something that you may have talked about in Algebra 2. It's definitely something you possibly could have taught in Algebra 2. It's definitely something you're going to see when you take your first year math class in college. Doesn't matter. I've talked about this before. It doesn't matter if you're a math type major, science major, anything like that. If you go to a 4-year liberal arts college, liberal has nothing to do with liberal and conservative. It just means you take a lot of stuff, okay? You don't just take what your major is. You take a lot of things because you're trying to be well-rounded. That's what a liberal arts college is trying to do for you. It's trying to make you well-rounded. So even if you take something that has nothing to do with math whatsoever, you're still going to have to take at least one, maybe even two math classes. And one of the favorite things that they teach in a first-year college math class is functions. So the stuff that we're doing today with functions is really, really important just to understand what it means. So let's do something really, really basic before we start getting into what a function is. Now, it has to do with functions. You're going to see in a few minutes that what we're doing right now is definitely going to relate to functions. But let's just do this. So what if I told you that if y equals 3/2 x, should be taking notes. I see a handful of you taking notes, but not the majority. Okay, so if you have this as an equation, what I want you to do is find what x is, but I got to tell you some things first. I wrote find the value of x. That's not correct. Find the value of y, it should be. All right, and so they give you a few different parts, like 4 different parts to this. So what if they told you that x was 2? This is basically a substitution problem. We're just substituting 2 into x in our little equation right here. So y equals 3/2 x minus 2. So y equals 3 over 2 times x. So in this particular problem, what is x? Well, it's 2. And then you're going to minus a 2. So it's just basic substitution. I take what 2 is and I replace the x with that value for x. All right? And then we just work it out. This isn't that big of a deal. What happens here? Well, the 2's cancel out. So 3 minus 2 is what? 1. So that's your answer, 1. Let's do another one. What if I said, this is part B, what if I said x was equal to 6? Then what is the value of y? So I'm going to go y equals 3 over 2 times 6, because it's times x, 6 over 1, and then finish it up. You got that minus 2 on there, so you got to put a minus 2. This works out real nice and easy as well, because 2 divides into 6 3 times. 3 times 3 is 9. 9 minus 2 is 7, so your answer is 7. There's a couple more I could do, but that's all I've got for right now. So I'm going to say a couple words here. I'll keep this up here. So the x, we're taking the x and we're putting it into the equation. Everybody see that? We're putting it into the equation. So x is called the input. That's what we're putting in, right? That's the input variable or letter, all right? And then what we get at the end, okay, what do we come out with? We come out with an answer. So what do you think that is? Y would be the what? If x is the input, what's y? It's the output. Okay? So that's really important, what we're going to talk about later. So I just want to make sure that you understand that. So, yeah, that's good enough. Let's do this. Let's do a graph, but I'm going to graph it a little bit different. I'm going to go back to Algebra 1 or even pre-Algebra when you first started learning how to graph. And I'm not going to do the y-intercept and the slope thing, okay? We're going to go way back to when you first started graphing. So you should be able to graph this pretty easy if I just said to graph it. That's all I said. You'd put the 3 at the y-axis or the y-intercept, and then you'd rise 1, run 2, put another dot, connect them, boom, you've got a graph. Easy. But when you first started learning how to graph, you didn't do that. Do you remember this? Does that bring back any memories? Yeah. When you first started graphing, this is probably what your math teacher did. They put a little chart, put one column for X and one column for Y. All right. So what you're going to do, you want to figure out what Y is and what's our input. What are we going to input? It's the X. Okay. So we're going to put in some numbers for X. Then we're going to throw them into the equation just like we did a little earlier. And then we're going to figure out the Y is. Then we got all these points. We can plot these points on a graph. And hopefully they all line up to be a nice straight line. What's the minimum number of points that you need to make a line? 2. Right. All you need is 2. But a lot of times we'll do a little bit more than 2 just to make sure that our line lines up the way it's supposed to. Because if I pick 2 and I messed up on one of them, I got a line, but it might not be the right line. So if I pick a third one and if they all line up, I could be pretty certain that the line is correct. If I pick a 4th or a 5th or a 6th, then I'm really, really certain that that line is the way it's supposed to be. Because I don't think I'm going to make the same mistake 5 or 6 times, hopefully anyway. All right, so let's put some numbers in here. We are multiplying by a half, so what do you think would probably be a little easier of a number to choose if I'm multiplying it by a half? Would I pick a 3, a 5, a 7?
Even number.
I would pick an even number. Very good. Thank you for answering. All right, so I'd probably pick an even number. Sometimes, you don't always have to do this, but sometimes I like to pick maybe a couple negatives. I like to pick 0 and maybe a couple positives. All depends on what the equation is. But let's pick a negative even number. What's a real small negative even number? It would be -2. So let's pick a -2. Let's pick a 0. Let's pick a +2. And just for the fun of it, let's pick another one. We'll go to +4. All right, just to see if they all match up. All right. 2024. There you go. Your year. So let's put in a -2 for this. I'm not going to show all the work just because of time, but let's do it in our head. If it's 1/2 times -2, what's 1/2 times -2? What's that going to be? It's going to be -1. And -1 plus 3 is? -1 plus 3 is 2. Okay? All right, let's put a 0 in for this. That's an easy one. 1/2 times 0 is 0 plus 3 is 3. All right, put a 2 in for this. It's a +2 this time. So 1/2 of 2 is 1 plus 3 is 4. All right? And really, if I just pick 2 of those, that's enough to give me my line. But I want to pick a few, and I'm going somewhere with this. We're not just trying to learn how to graph. Okay, there's a reason for this. All right, if I put a 4 in for this, what's 1/2 of 4? That's 2 plus 3 is 5. Okay, so now let me come over here. Let's grab this graph. Let's put it right here. Let's just make it a little bit bigger so we can see it. Okay, and now let's put some points in here. And if we did it right, they should all line up and make a straight line. Would you agree? If we messed up, if one point is like way out here and the other line is here, we messed up somewhere. We either messed up with the line or we messed up with that point, that outlier point. So let's put some points in here. Let's see if they all line up to be a straight line. -2, 2. -2, 2. Oops. Why is it that X looking thing? I don't know. 0, 3 is right there. So technically, I could stop right there, connect the points, and I've got my line. But let's put a couple extra in just to see if it's going to work. So let's put a 2, 4, 2, 4, 1, 2, 3, 4. Yep, so far they match up. And then we got 4, 5. 1, 2, 3, 4. That's 4, 5. And sure enough, look, they all line up. So I can be pretty certain that this is correct because if all 4 of them line up, hopefully I didn't make the same mistake 4 times. But yeah, that's it right there. Okay. Now, the reason that we graph the line is to talk about this. Okay, we've got input, we got output. So all the X's were our inputs. All the Y's were our outputs. So we picked values for X. That's the numbers that we put into it. Okay, and then these are the numbers that come out of it. After we put it in, we get numbers that come out. The book does this, and I don't know if the other books that I've taught college algebra actually do this, but this is something that my my professors in college would talk about this all the time when they talk about functions. They talk about the function machine. All right, so this is a function machine. This is a very basic function machine. They actually kind of make it look kind of cool in the book. If you look in the book, forget what page it's on, but they make a machine that looks a lot fancier than this. But here's my function machine, okay? And what does this function machine do? All it does, it takes whatever you're going to input and it puts it into the machine. And what does the machine do? It takes half of the input and then adds a what? 3. That's what my machine does. And then it pops out an answer, okay? So I could put any of these in here if I wanted to. All right, so let's put another number that we haven't used yet. What would be another one? 6, okay? 6 would be good. So let's do that. So I put a 6. This is like a little funnel, right? I'm putting the 6 into here. It drops into the machine, and it kicks out an answer, all right? It's just to visualize. That's all it is, all right? You can write it however you want it. It's not going to be on a test, no. So watch. If I stick a 6 in here, what does the machine do? It takes half of it. So what's half of 6? It's 3. Plus 3 is what? It's 9. It kicks out. I'm sorry. It's 6, all right? Half of 6 is 3 plus 3 is 6. I don't know what I was thinking. So it kicks out a 6. So when my input is 6 and my output is 6. This has a lot to do with functions, all right? So let's let's talk about this. Now, did you notice how each of these, this -2 only has an answer of 2, correct? Put your hand down. This value right here has a value. It just has one value. It doesn't have 2 values. This is what I'm getting at. What? No. This has a value of 2. What do you get? You just get one answer. Everybody see that? Every one you put in, you'll only get one answer. When that happens, when you have that situation, then you have a thing called, what did I say the lesson was? The name of the lesson? Then you have a function. You're just going to have to wait. It's called a function. All right? So when you put in an x and you just get out one value for y for that x, okay, that's considered to be a function. All right? And you're probably thinking, well, how in the world would I get 2 different answers for y? Well, I'm glad you asked. Let's do one. So watch. Y equals the square root. I'm going to put a plus or minus right here. Everybody look at this. All right, so let's do this little thing right here, okay? This is my x, this is my y. So I'm going to put some numbers in here. Now, let's be specific on the type of numbers I want to put in here. All right, so I'm taking the square root, even numbers. Do I want to put a 2 in there? What's the square root of 2? What? Do you guys know what square roots mean?
Oh, wait, I thought you were saying what was the opposites that you had before.
The square root. I'm not going to put a 2 in here because the square root of 2 doesn't come out to a nice even whole number, okay? But I could put a 4. Let's put a 4 in for x, okay? So if I put a 4 in for x, I'm taking the square root. What's the square root of 4?
2.
It's 2. But, listen, I'm not going to explain about this plus or minus. I just don't have time to do that right now. I was going to do that earlier, but I don't have time. But what do we have? We got a plus 2, right? And we have a what? You just unplugged everything. You just unplugged all my stuff. No, everything shut off. So you hit the power button or something. So if you put in a 4, look what you get. You get a positive 2 and a negative 2. Well, let me show you what I'm doing. Okay, if you get a 4, I get out a 2 and I get out a negative 2. All right. What's another number I could put in for this that comes out? 6? Square root of 6? 8? 9. Thank you. Put a 9 in for that, okay? What's the square root of 9? It's 3, but it's also a what? A plus and a negative. Well, let's not worry. There was a reasoning for this. I'm not going to listen. Just listen. Don't ask questions right now. Normally I would take questions, but I don't have time. This right here, there's a reason why I did that. I don't have time to explain it. Here's what I want you to see before we leave. Each value of x has how many y's? It's got two answers, doesn't it? If I put in a 4, I actually get two answers. What did I say must be true about a function? When I put in one value for x, I can only get out what? One value for y. So this time I get two outputs. Okay? So it's not a function. So this is not a function. And you're going to have a lot of problems where it asks you, is it a function or is it not a function? All right, well, like 3 people were actually paying attention, but there you go.